Good morning, everyone. Happy Wednesday. It's nice, sunny outside today. So hopefully, weather will be nice. So I'll wait for another minute and then we can talk. Anyone has any questions about the last class that we discussed in the last class? All right. All right. Once again, good morning, everyone. So last class on Monday, we started chapter 3. So let me quickly review what we did so far in chapter 3 and then pick it up from there. So last time, so we started with chapter 3. So chapter 1, we talk about the distribution. Let me just go from here. In chapter 1, we talk about looking at the data, the distribution. In chapter 2, we look at the relationship between bivariate data set. And this chapter, we are talking about how do we produce data. So when we are saying producing the data, we need to produce data in such a way that it is free from bias. And how do we do that? So last time we worked with the sampling and we learned the sampling technique using table B. We did not get to finish everything, but we learned how to look at table B, how to look at the data, organize them in the order, label them, and then we use table B to find the random sample of the certain size. So we talk about so we started with 3.3. We did not cover 3.2, which we are planning to do it today. So in 3.2, we discuss what is population, what is sample. So when we are talking about the population, we are talking about the entire group of interest. So if this is my population, this is the whole group of interest. Let's say this is I'm talking about UNCG. Then UNCG, entire UNCG is my population. And then I take a sample. And when I say sample, a part of this population, then I work with this sample and then use the results of the sample to talk about the population. So when we say population, most of the time population is unknown to us, and we are going to talk about more population mean and variance and all that stuff in chapter 6 and 7. But again, when we are talking about population, this is the big picture or entire group of interest. So instead of working with the entire group, we work with a small part of that group. And then this chapter, we are learning how to get that group or how to collect the sample. What are the good ways of collecting the sample? And we also talk about the bad ways or the cautions or the precautions that we need to do when we work with collecting the sample. So when we say sample, how do we collect that sample? We talk about some design. So we did not talk about much, but we talk about convenient sampling. We talk about volunteer sampling. We also talk about randomization, and we discuss about sample random sample. So this is the last topic that we were working in our last class, simple random sampling. And as the word says, simple. So we are doing random sampling, and when we say random, we say chance process. So every single subject has equal chance of getting into that sample. So we talk about random sampling. The word says simple random sampling. So we are doing a random sampling, but in a very simple way. And that simple way can be either using your software random digit generator, or you can use your calculator to generate random numbers, or you can use table B, or if your sample that you are picking from the population is small, you can take a box, or as mentioned in the slide, you can take a hat, label all the names, put it in the box, and then pick one at a time. And then let's say I have n, and that n is 15. So first I pick one random sample from here. And again, when I'm saying random samples, so that means there are 15 names here, so on. And each of them has equal chance. And when I shuffle the box, I can pick one name out. So now my n is left as n minus 1. So there were 15. Now I have 14 sample. Then I'll pick one out, and then 13. And then from there, and if I need to pick 4, so this is my 1, 2, 3, and 4. So again, when I'm talking about random, I have equal chance of picking any number between 1 to 15. And once that number is picked, now we are left with 14. Then we'll put 14 again in the box, shuffle it, and then pick one. And similarly, if you're using a software or a calculator, they can generate random numbers. If you tell me between what is your minimum, what's your maximum, it's from 1 to 15. So it will give you random numbers. And again, when we say random, so every single subject has equal chance getting into the sample. If I am collecting a random sample of size 4 from your class of 45 students, and let's say all of us are collecting a random sample of size 4 from this 45, not necessary that my random sample will contain the same sample, same observation, or same subject as your random sample. Since we are saying random, every subject has equal chance to getting into the sample. Let's say I pick a random sample of size 4 from this. I label everything, I get this. And if I get this 14 again, this is not a possibility because I already picked 14 and I took it out. So again, if you see, we are going to use table B. In table B, if you get the same sample again, we do not pick it again. Because if I am talking about your class, only one subject has label 14. So if I already picked that, I cannot pick this one. So then I take it out. So my next one is, let's say, 16. So if this is my random sample, not necessary that you will have exactly the same random sample. Maybe one digit is same, or 2, or 3, or maybe all 4, or maybe none. So again, when we are saying randomization, it's completely by chance. And when we are using table B, we are doing the randomization. Every subject has equal chance, but what is different than this? We all get the same sample. And when we say same sample, that means if I am using the randomization using the table B, then I need to pick a line. And that line, let's say it's 130. So all of us are using the same line, then we all get the same sample. We are still doing the randomization because table B has different lines, and each knowing the first number is not going to affect the chance of my second number in the line. So they are independent of each other. So again, when we are using randomization using table B, then we are labeling our sample the same way, and then we are going to get the exact same sample. But if we are using different lines, let's say I use 130, but you're like, I don't want to use 130, I want to use line 125. Somebody's used 120, somebody used 141, then not necessary, then we all have the same sample because we are using different line. So in your homework assignment, the questions specify the line, or it provides you the line. So when you pick up and the sample from that particular line, you all have the same answer, or you can say that you all have the same sample. But again, in real life, you use your software or calculator, mostly some kind of software, to do random digit generator, and it gives a complete random sample. If you do it now and after 5 minutes you do it again, your two samples will be entirely different, or maybe they have something common, or maybe everything common, but not necessary. So that is randomization. And last time we were working on this example, we did not have enough time. So let me start from here. So if we are given 28 hotels, and the question says that use the random digit provided to select a simple random sample of 4 hotels. So if we are using a random digit table, and that line, specific line is given to us, then we are going to use that line to pick a sample of size 4. And how do we do that? The first thing, we need to label them. And we need to label them how? So that we all have the same answer. We need to arrange them in alphabetical order. And once you arrange them in alphabetical order, then you start labeling from 1, 2, 3, 4, and look for or let's say, what is your population size? So n is your population, and I have 28 hotels. So if I have a population of 28, that means I'm talking about two-digit number. And when I do the randomization and doing the labeling, all my labels should have two digits. So when I start with 1, I put a 0 in front of that, because 01 means again 1. But now it's a two-digit number. Same thing, 02 up till 09, and then you have all two-digit number up till 28. That is the first step you need to do. Organize them in alphabetical order and then label them. And again, this specific example, we are organizing them because we all need the same sample, or we all looking for the same sample size. But again, if you do not want to look for the same sample size, you don't have to label them in alphabetical order. You can label that any way you want to. And you don't have to use the same line in table B. You can use any line, or you can put all these names in a box and pick 1, 2, 3, 4. And that is your random sample of 4 hotels. So once you label them, the line is given to us. What do we need to do to get the sample of size 4? Since our population is two-digit, we will look at the line and start doing the partition, or start selecting 2 numbers at a time. So this is my first 2, 69, and then 2, 2, and I'll keep on doing until I get my 4 numbers. So let me just stop here and see if I get my 4 numbers from here. So I look at 69. Does my population contain 69? No, my maximum is 28, so this is not in my sample. 05, do I have that label? Yes, I do have that label, 05. So that is my first sample. 16, yes, I do have 16. 48, 48 is over 28, so I will cross this out. 17, yes. 87, more than 28, cross. 17, as I just mentioned, since I already picked 17, I cannot pick that again. I already picked 17, so I cross that number out. So I cannot pick that number again because it is already in my sample. 40, no. 95, no. And then again 17, 17 already picked, so no. So I got 3 numbers. I still need one more, so I will still keep on going until I get that number. So let's start again. 84, no. 53, no. 40, no, because they are all more than 28. 64, no, no, no. And 20, yes, I do have 20. So as soon as I get my 4 checks or 4 sample, I'll just stop here. And then I can see 5, 16, 17, and 20. They are all here, and then I will label. Look at the label 05, what I have, Beach Castle, and then Radisson, Ramada, and C. And in the order you get, you label them. So you get 5, 16, 17, and then 20, and that is your 4 sample that you picked from a population of size 28 in a random manner, or you can say that you did simple random sampling. You did simple random sampling means you look for the randomization. So you look for equal chance in each sample when you pick, and at the same time you did it in a very simple way. You use random digit table and then you just cross it out and then pick your 4 sample. So I'm using the same example. Let's say I'm using the same example. Instead of 28, I just have 8 observations. So I have just first 8 observation and they told me, let's say I'm talking about only up till here. And I need to pick a sample of size 2 from here. If I need to pick a sample of size 2 from here, so that means I'm talking about 1, 2, 3, 4, 5, 6, 7, 8. So I'm talking about one digit. When we say 28, our last is 2 digit. Here we are talking about 1 digit. So we do not need to label them at 0, 1, 0, 2, 0, 8. We can just label them as 1, 2, 3, 4 because my last digit is, or my population is in 1 digit. So I can just label them as 1, 2, 3, 4. And when I label them as 1, 2, 3, 4, 5, 6, 7, 8, how do I use my table A? So when I use my table A, I'll do the partition using 1 digit. So I will do 1 digit partition because my maximum is 1 digit now. And from there I can pick 2. So I can see 6, yes, 6 is in my population. 9, no. 0, no. 5, yes. So my 2 sample is 6 and 5. So I will go to 6. My first sample is Best Western and my second sample is Beach Castle. So again, you look for your population. If it's 2 digit, 1 digit, 3 digit, let's say it's 3 digit, I have 927. Again, when we are talking about 3 digit, we are not going to put them in the alphabetical order and label them. We will use software to work on that. We are not even going to use calculator. You can use the calculator, but you are not labeling all of them up till 927. But again, in case you have to, then what you need to do, then you do the partition in 3 digits. So every 3 digit you do the partition, and then what you need to label, you need to label as 001, 002 to make it 3 digits. And again, there will not be any question in your homework or quiz where you have to label them for 3 digit. But for your knowledge, if you see something like that, it is the same process. You are still selecting a sample of size 4, 10, 15, 20, depending upon you are working with 1 digit, 2 digit, 3 digit, 4 digit. You can just label them, and the partition will be done in such a way depending upon what your population is. If it's 2 digit, draw a line after every 2. If it's 3 digit, draw a line or a partition after every 3 digit. But if it's 1, again, you do not have to label as 0102. 1, 2, 3, 4, 5, 6, whatever your 1 digit maximum is, then draw a partition after every 1 digit, and then you get that. So 1, 1, 1, 1, 1, and keep on doing. Questions so far? How to do simple random sampling. So simple random sampling is the key, or you can say the important part when we talk about other sampling methods as well as designs. So when the next topic 3.2 that we are going to do, we will talk about sample design. When we are talking about not sample, experimental design. So when we do experimental design, we work with the design and then we do the simple random sampling there. So simple random sampling is an important tool or important part when we work with experimental design. So any questions about how to do simple random sampling, or what do we mean by random sampling, or what do we mean by sampling? All right, if no questions, so let me move to the next part. So examples of, so first we talk about simple random sampling. And simple random sampling, some places you will see SRS. So this also talks about simple random sampling. The next one is called stratified sampling. And when we are saying stratified sampling, stratified word comes from strata. And strata means groups. So when we are talking about, or when we are making groups and then doing the simple random sampling from those groups, we are talking about stratified sampling. So stratified sampling, what you do first, classify the population into groups, or you can say stratas. And choose the probability sample from each group, or you can say strata. So when we are talking about stratified sampling, first of all, you need to classify the population into groups and then choose the probability sample from each group. And let's use the same example. We have 28 hotels and we did the simple random sampling in the first tab and chose 4 hotels. So this is what we did in simple random sampling. Now, how we can use the same example to talk about stratified sampling. So when you are doing stratified sampling, and as mentioned, first classify the population into groups or stratas. So when you do this, first make the groups of these 48 hotels in a specific way, or let's say we make the groups using their what to say, the levels. And that's like, is it a 1-star hotel, 2-star, 3-star, 4-star, or 5-star? So how much is the rating for each hotel? So if you are looking for the rating, and let's say I'm looking for 2, 3, 4, and 5-star. So I'll see how many out of 28 are 2-star, and then those will go in this group. How many of 28 have a rating of 3-star? How many of them have a rating of 4-star, and how many have the rating of 5-star? And when I'm making these groups, each group will have different number. It's not possible, or it's not always possible that I can divide 28 into 4 equal parts. Like, okay, 2 of them have 1/4 of them have 2-star, 1/4 have 3. Not necessary. Maybe there are more 2-stars, or more 3-star, more 4-star, more 5-star, depending upon what kind of hotels you have in your population. So once you divide them into groups, and since I'm picking 4 hotels, so I'm dividing into 4 rating groups. If I need to pick a sample of size 5, I can divide into 5 groups, 1, 2, 3, 4, 5, or no rating, depending upon how many sample I'm picking. And then I will do random sampling from each of group. And then I'm picking one hotel from each group. So when you do a simple random sampling, let's say you have 5 hotels here out of 5. Again, either you can do random generator, you can do table B, you can use a box, and then you can pick one hotel out of these 5. Again, through chance process. It's not like, okay, this is the first hotel, or I stayed in this hotel, I personally like this one, or somebody gave a very nice review, so I can pick this. No, you are creating a bias if you're just picking one. So you need to give each of them an equal chance to get into your sample. Then you pick one from here, one, and then when you look at these, you have 4 hotels. You get 4 hotels here just by doing simple random sampling from 28, and then you did the second sampling using the groups. And again, you can make groups depending upon what category you have. Here we use ranking. You can use how many hotels are in East, how many in West, how many in North, how many in South. So you can look at their position wise, and then you can make these. And from there, you can pick. Or again, how many hotels have a room available from between 100 to 200 range per night, 200 to 300. So you can make any group or category depending upon what information you have. But the procedure is still the same. Once you make the group, and again, group, you are not doing anything. You are not making group according to your choice. You are making the group depending upon what information you have. So first step in stratified sampling, groups, and groups are information about the groups is known to you. So you are not contributing anything to that part. So you know groups ahead of time. You have that information. So once you have those groups, you are doing simple random sampling from those groups. And then you get the required sample. So that is your stratified sampling or group sampling. And I'm talking about sampling, make sure you understand this part clearly. If you have question, you can ask me. And the thing is, when we are going to talk about next topic, 3.2, experimental design, how I'm saying stratified sampling, we have block design, and similarly other that is very similar to stratified sampling, but how do you differentiate if it's a sampling or a design? And I'll explain you when we come there. So this is the second part, stratified sampling. The third one is multi-stage. And when we are saying multi-stage, read the word multi-stage. So multi-stage, if I split this word into two, multi and stage. So that means many stages before you do your sampling. So you need to work with many stages and then you do your simple random sampling. And what does that mean, many stages? When we talk about stratified sampling, we can think of stratified sampling as first stage is your group, and from that you do simple random sampling. So you did only two steps, right? So when we are talking about multi-stage, you are doing more than stratified. It can be 3-step, it can be 4-step, it can be many step. So we are doing, or we are splitting the population into different stages. And again, that stages or that groups are known to us. So we are splitting into different stages and then doing random sampling from here. And I'm using the same example. So you have 4 hotels depending upon their rating, 2, 3, 4, 5, and we did the simple random sampling from there to do the stratified sampling. When we talk about multi-stage sampling, this is our first stage. The second stage that I pick the hotels depending upon their rating. Next, how many of them have complimentary breakfast, or how many of, let's say, complimentary breakfast. So let's say I have 5, 6 here and then 2. And similarly, you can get some numbers. And this is first step, first stage. This is my second stage. And I can do simple random sampling from there. And then I get a sample of size 4. But I did not get straightforward. I did some further steps. If I need to extend it a little bit more, instead of doing this, I can do one more stage. How many of them out of that have a pool, swimming pool? And then you will get 1, 2, 3, 4, depending upon how many you have. And then from there, you can do simple random sampling. And here we are just taking a sample of size 28. What about if the sample of size 500, 5,000? And from there, you have a big amount here. And from there, you're actually think of that way. You're trimming down. Let's say I have 20 here. From 20, I just get 5 out of 5. I just pick one. So when you're talking about multi-stage, you're talking about many stages before you do this simple random sampling. In this case, we did 3 stages and then did simple random sampling. In this, if I do simple random sampling from here, I do 2 stage. If I'm doing simple random sampling from here, so I'm not talking about multi-stage, I'm talking about stratified sampling. So multi-stage sampling is an extension to stratified sampling. Simple random sampling, we are doing in every. We are doing simple random sampling in stratified as well as multi-stage. The only difference is when we talk about multi-stage, we do stratified, but keep on doing. So we extend the stratified sampling to get multi-stage and then get simple random sampling. Again, when we are doing simple random sampling, we are giving equal chance to all the subject in that particular group that or subgroup that we have. So this is multi-stage sampling. The fourth one is called systematic sampling. And again, as the word systematic, we are using the word systematic. It's saying that when we are doing sampling, we set up some kind of system before doing the sampling. So you set up a system. And how do we set up a system? So when we are talking about systematic sampling, we need to set up a system. Let's say I'm using the same. Let's say we have 28, my n is 28, and I'm looking at a sample of size 4. So first I will set up a system, let's say K. I'm looking for K, and K is your n divided with your sample, how much sample you are looking for. So this is 28 divided by 4, which is 7. So once I get that number, I will lay them out 1, 2, 3, 4, 5, 6, 7. And so this is the system that I created. What I looked at what's my population, how much sample I'm looking for, and then I'll calculated you can call it anything. I just said K, the number. It's 7. So then I lay out, and then I use random sampling to pick one number from here. You can use that random sampling either calculator, software, or your table B. Let's say I use the calculator, and calculator give me my first number as 4. So this is my first sample. So my first sample is 4, and then 4 plus 7 is my next sample. So I added 7 to this, and then 11 plus 7, and then 18 plus 7. And again, when I'm saying 18 plus 7, it will be 25, and I have a sample of size 28. So all these numbers are between my 1 to 28. So I set up a system that every 7th number after my first number that I picked, that will be in my sample. So my first number is 4. If you use calculator, use table, not necessary your first number will be 4. Maybe you just get 1. So then your system is 1 is my first sample. Then every 7th one is in my sample. And similarly, somebody can get 5, somebody gets 7. So it depends. Again, we are doing random generators. So it can be any number between that. So I set up a system that this is how I am going to do the sampling. And again, I'm doing randomization here. I'm not creating a bias. I'm setting up a system, but at the same time, I'm doing randomization. This number, 7, definitely we all will get this when we divide with this. But I picked this number by randomization. I did not say, okay, I work with 1 or I work with 7. I picked this number from randomization, and then whatever I'm adding to it, the next number, I don't know who is on 11th place, who is on 18th place, who is on 25th place. So everything is coming through randomization. Or we are doing simple random sampling. You can say once you create that, then you are picking those numbers using simple random sampling. But at the same time, I'm setting up a system. So let's say I am looking for a set of a sample of size 4 from your class. And then I set up a system and I'll say, whoever is the fourth person joining the Zoom call today will be my first sample. I do not know, you do not know what number you are joining the call. But as soon as the fourth person joined the call, that is my first sample. And then I'll keep on doing 4 plus 7. Whoever is the 11th person who will join the call, that will be my second sample, then 18th, then 25th. So again, when we are talking about this, I do not know who is joining at the fourth place. I do not know who is joining at 11th. So I created the system, but at the same time, I have randomization going on because every single subject has equal chance getting into the sample. So that is systematic sampling. So you set up a system and then you follow that system. And let's say I do not want to go through all this trouble, and I said that whoever is the first 4 people in joining the Zoom call, I'll take that as those 4 people or those 4 subjects in my sample. And those 4 will be my sample. Do you think that is called random sampling or systematic sampling? Or do you think it will suffer from bias or anything that you can think of?
Will it suffer from bias because it's only people who get to class early?
So this is, again, as she mentioned, that this is not considered as random sampling. When, let's say, the class time is from 10 to 10:50, and some students have class at 10 o'clock, that class just end at 9:55 or 10, then they definitely join the class late. But some students have no class before that, and they connect at 9:50 or 9:45 as soon as I connect my link, and they are all on their Zoom, on my Zoom call. So that means, again, I'm not giving every single subject an equal chance of picking. I'm just taking those subjects according to my convenience because I say, I don't want to go through all this trouble. Let me just collect the sample of size 4 who will join before the class or right when I start the class so that I don't have to keep on navigating and checking who is the fourth person, who is the 11th person. So that is called my convenient sampling. And when I say convenient sampling, we discussed it in the last class. That is according to my convenience, but not through the randomization. And that will bring the bias in your survey. So to eliminate the bias or the chances of bias, we do randomization. So randomization is the key to eliminate bias. So that is one thing that I want to discuss. Let's see what I miss, and then we can go from there. So we talk about simple random sampling. Let me just quickly read these definitions. So the basic idea of sampling is straightforward. Take a simple random sample from the population and use your sample results to gain information from the population, information about the population. Probability sample, as we mentioned, chance process. When we are talking about random sampling or the sampling, probability models are the best model because they provide you equal chance of picking the subject. So probability sample is a sample chosen by chance. We must know what samples are possible and what chance of or probability each possible sample has. And again, in chapter 4, we will talk about how to look for the probability of each sample or how to read the results using the sample. What is a probability model? When we talk about probability models, what are the rules? So everything we will learn in chapter 4. Sometimes there are statistical advantages to use more complex sampling methods. One common alternative to a simple random sampling involves sampling important groups, and that is called your stratified sampling or stratas, or you can make within the population. And these samples are combined to form one stratified random sampling. So again, as I mentioned, when we talk about stratified sampling, we make groups or stratas, and then we do simple random sampling from there, and then we combine that. So if I pick 1, 1 or 2, 2 from here, and then we combine, and that is my simple random sample. So to select stratified random sample, first classify the population into groups of similar individuals. Again, where it says similar individuals, so we make groups using the rating. Rating is 2-star, 3-star, 4 stars. So they should be similar in some way. And again, you do not have to make that group. That information is provided to you if we are making these group on the basis of their regions, on the basis of their ranking, on the basis of their cost per room per night, on the basis of the facilities they provide, on the basis of the luxury. So it all depends what information is given to you for each strata. Then choose a separate simple random sampling in each stratum and combine these to form a full sample. Multi-stage, they provide you an example here, but I think I already provided you the example from here. We did the rating, and then from rating, we did another group depending upon do they offer complimentary breakfast or not, and then we look at if they have the swimming pool or not, and then you keep on doing different stages depending upon how many stages are given to you. So one stage stratified, more than one multi-stage. They can be 2, 3, 4, 5 depending upon how many stages. So multi-stage, many stages. One stage where we are making the groups and doing simple random sampling, that is your stratified. Anything other than that is multi-stage. And we also talk about systematic sampling. And systematic sampling, the information is not provided in your slide, but I think I explain it to you guys. But again, if you have any questions about systematic sampling, let me know. Now, what are the things you need to be careful when you work with sampling, or when you work with different sampling models? So you are working with simple random sampling or stratified or multi-stage. What are the things you need to be careful? So first, last time we discussed, let me just write here, convenience. So we already discussed that. And we also talked about voluntary. So when we say under coverage, if we read the word under coverage, so that is covered under something. So think of that like when we talk about under coverage occurs when you work with, when you know what population you are working with, but when you collect the sample, then some of the population is left out in the process of choosing the sample. So when you try to collect the sample, that sample is not representing the whole population. Some part is left out, then we are talking about under coverage. So not covered fully. Non-response, and sometimes we get confused with under coverage and non-response. So let me explain you what non-response is, and then we'll see how these two are different. When we are seeing non-response, so again, the word non-response says that you did not respond, or the participant or the subject did not respond to your survey. When we are saying non-response, did not respond, that means that subject was chosen in the sample using simple random sampling. So the subject is already chosen. So let's say if I'm looking for a subject of, if I'm looking for a sample of size 100, so I collect that sample of size 100. But out of these, 20 of them do not participate in my survey. So that means they refuse to participate in my survey. And they said that they either did not respond back to my survey. Let's say I send it via email. I got the response for 80 of them, but I did not get 20 back. Or let's say if I'm doing that survey over the phone. So 80 of them give me the answers, but 20 of them either gave me partial answer or no answer or did not pick up the phone. So that is talking about non-response. So non-response occur when an individual chosen for the sample. So individual was already picked up in the sample, but they refuse to answer, or they refuse to answer, or they are not, let's say, not reachable or cannot be contacted or refuse to participate. Either way. So out of 100, so I started with a sample of size 800, a sample of size 100, and I got only 80 of them responded. So now my sample size is reduced from 100 to 80. So let's say if I'm looking for a population, and again in later chapters, we will learn what is a good sample size for a specific population to work with. And let's say this population, I need a sample of size 100. And if I need a sample of size 100, I got only 80 of them responded back to me. So now I am left with a sample size of 80 only. So is that enough to work with the corresponding population? And if the sample size needed to be 100 and I'm just working with 80 because I'm working with non-response bias, my results are not good. So this thing is, or this sample is suffering from non-response because I started with 100, but now I'm using only 80 to find the result and then take the decision or take the conclusion about the population using this 80. So my survey will suffer from non-response. Systematic pattern of incorrect responses in a sample survey leads to response bias. Let's say I have 50 questions in the sample in my survey, and I look at their answer. Okay, first right, second wrong, third right, fourth wrong. So that shows me that if I see there is a systematic pattern of going yes, no, yes, no, yes, no, that means that particular subject does not pay attention to the survey. They just fill the survey with yes, no, or 1, 2, 1, 2. So that will also bring bias in my survey. And that's called your response bias. And we also say voluntary bias. And again, when we are saying voluntary response bias, again, in voluntary response bias, people who have a strong opinion, they will participate in those surveys. And for example, in like a call in a radio show, they try to attract the people who have or you can say opinionated people, and they want to take their opinions. So if they have strong opinions, only those people will try to reach, and only those people will provide their opinion. So that we call as voluntary response bias. And we also have voluntary bias. How voluntary response bias and voluntary bias differ? When we are saying voluntary bias, so how people react to the situations. Let's say if a new drug will be tested to see if it is effective for a specific treatment, let's say for diabetes, and if they are looking for that, and if that drug is effective for the diabetes and they are giving some compensation, let's say they are saying, okay, whoever will be included in the survey will be given $500 as a compensation. Then again, most of the subjects who will participate in that survey will, or in, maybe they are coming from low income, and that will give us a voluntary bias that the study might be looking for if that particular, you can say, if this disease, if this drug is effective for the disease in general, but they might not be getting all the subjects coming from all over. They are just coming from maybe just the low income because the compensation is given to. So that is considered as the voluntary bias. And we talk about convenience also. And sometimes the question wording is also not good. Sometimes, like we say, the question wording bias. Sometimes the questions are so confusing. Sometimes the words are not used appropriately, that the respondent does not feel comfortable responding back to your questions. So that also influence your sample survey. And again, it says that insist of knowing the exact question asked, the rate of non-response, and the date and method of the survey before you trust the poll results. So just taking the sample, get the result, and just say, okay, this is my result is not enough. We need to take a look at all the things, or we need to consider everything before we trust our results. So I guess I will stop here. So we are done with 3.3, and we will talk about 3.4 in the next class. So most probably we will be done with this chapter on Friday's class. Thank you, everyone, and I'll see you guys on Friday.
Thank you.
You're welcome.